I wanted to take a moment to talk about contour lines. So when learning about topographic maps, it's probably one of the things that students have the most difficult time visualizing how that works. And so we know that a contour line is a line of equal elevation. So if you were to walk along the shoreline of the ocean, you would be at sea level. That's considered the 0-foot contour. And so you could walk along that shoreline and you know you would not be going up in elevation or down in elevation. You're always just at sea level. So that's an easy one to visualize. But when we get into like hills and valleys and things, it can be a little more difficult. So let's take an item that we're mostly familiar with, which is going to be a 4-sided pyramid, and see what would that look like if we were to draw contour lines on it. So here is my pyramid. So you can see the side face on the right and the front face is the one we can see. The two faces in the back are going to be behind. So I've got little dotted lines there so you can kind of visualize what that looks like. And if I were to walk around the base of the pyramid, assuming it was on a flat surface, I would not change elevations, right? I could walk along that pyramid base and I would walk along the back of it as well and make a complete lap around, and I would not have gone up or down. I didn't climb the face, I didn't step away from it, so I'm just at that elevation. And so let's say that that elevation is 100 feet. Okay? Now let's say that I climb up the face of the pyramid a little bit, and I'm going to go right to here, and I'm going to walk along that face, along the side of it. I'm not going to go up or down. I'm just going to be walking in a straight path there. And I can walk all the way around it there as well and loop back to my original location. And let's say that I had gone up 10 feet to do that. So this would be the 110-foot contour line. And I could maybe climb up one more, another 10 feet. So I would do another lap, something like this, loop down, and that would be my 120-foot. Let's put a little dash there for the foot mark. And so what I've done here is I've created what's called a 10-foot contour interval. So 10-foot contour interval, because I'm drawing a line every 10 feet in change in elevation. So let's think about what this would look like on a map view, because this is a 3-dimensional object that we're drawing these lines on. So if I were to take this to a map view, so here's my map, what I would see is my 100-foot contour interval would look something like this, just a square. So that's, you have to picture looking straight down on that pyramid. It really would just be a square, and I would label that with 100 feet. And then my next one would come in like this, and that would be my 110 foot. And then I would have my 120 foot here. And then I might have a few more that come in something like that. So that would be 130 foot, which I don't have room to label, but we'll just assume that since we know we have a 10-foot contour interval. And so we can see what this would look like. We've got these concentric squares in this case that are building up to a peak that's indicating increasing elevation. And so when we look at hills and things on contour or on topographic maps, normally they aren't going to be really angular like this. They might be rounded, but it would be the same concept. So you would have some kind of circular pattern, something like this, indicating that you were at lower elevation here, and as you walked up, you get to the top of the hill, and then you would walk back down again and get to that original elevation that you started at. So same thing here, if on this pyramid you were to walk up the straight face, you'd get to the tip, and then you could walk back down the other side and get to the same elevation you started at. So same thing, go up, up, up to the tip, and then all the way back down again. Now another interesting thing about this you'll see is we've got kind of these V's that are generated. So we've got this like V shape right here to kind of tilt your head. And what this is indicating is that there's a ridge. And we can see that on the actual pyramid. We know that pyramids have ridges where their two sides meet. And so if I were to draw this, this would be the ridge in that kind of map view of things. And so it's just to point out that the V's that you see in maps or in contour lines, when the V is pointing toward the lower elevation, it's a ridge. And so here we can see this is they're not exact V's, but they're kind of like V's. And so this would also be a ridge, and the V's are pointing toward the lower elevations. Now, if the reverse is true, if the V's are pointing this way toward the higher elevations, we know that that's a valley. So it's the opposite. And your lab manual covers that concept, but hopefully that brings a little more to life with a concept of a pyramid, which is something hopefully you can visualize.